This video we're going to look at improper integrals and how we deal with improper integrals. So first of all, what is an improper integral? Proper integral is defined as an integral for which the integrand, so that's the thing that you're integrating, is either undefined at one or both of the limits or at some point in between them. So if we look at a couple of these ones here, basically in this what you're looking for is when are you going to have a zero on the bottom line, because a zero on the bottom line is going to be a problem, or else when is one of your limits infinity. So here, this one is improper. It says here it's improper because one of its limits is infinity. This next one is improper because if you put 0 in, you're going to have a 0 on the bottom line of a fraction. Square root of 0 is just 0. And likewise, the same one, 0 would be in between -1 and 1. So again, you're going to have a 0 on the bottom line. And the next one, you're going to have one of your limits is infinity. So all of these are going to be what's called improper integrals because they're problematic. They've either got a 0 on the bottom line or they've got maybe one of your limits is infinity. So we're going to look at a couple of these. So we're going to scoot on to the examples of these and look at a couple of these just. Okay, so the first example says, find the possible values of, and first one is the integral from 1 to infinity of 1 over x squared. So to do this, we're going to replace, so in number 1, what we're going to do is we're going to replace your infinity sign by just a, and then integrate and see what happens. So first of all, I can't integrate this anyway at the minute because it's not in index form, so rewrite it in index form as this. And then we'll go across, and then once we've integrated, raise the power by 1, goes up to x to -1, and divide by the new power. So divide by -1 is just going to be minus. So that's what you've got between a and 1. And then put that in. So that's going to be the same as -1 over x, and that's between a and 1. And if you put that in, that's -1 over a, then minus 1 over 1. So that's going to be +1, just is what it is. Okay, so remember, so what we had to do here, we replaced infinity with a first of all, but it still was infinity, so we can't just forget about it. So we'll just say as a tends to infinity, what you're going to have is the 1 over a goes 1 divided by infinity. Well, if you think even 1 divided by a million is got a tiny number, so if you do 1 divided by infinity, that tends to 0. So that means, so the value of the integrand, or the integral, sorry, of the integral is just +1, and that's it. Okay, the next one, we were integrating this thing. I'll just write that down again. We were integrating from 0 to infinity of the square root of x dx. So we're just going to, what we're going to look at is the integral. What we're going to look at instead is the integral from 0 to a, that's a 0 to a of the square root of x. And again, we get that in index form first, that's x to the power of a half. Integrate that thing, raise the power by 1, it goes up to 1.5, and write it as 3 over 2. Divide by the new power, dividing by 3 over 2 is the same as multiplying by 2 over 3. And then it's between a and 0. And then if you do that, that will become, it's just going to be 2a to the power of 3 over 2, and that is over 3. Okay, so remember, we replaced our infinity by a, so let's just go and look at what happens. As a tends to infinity, a to the power of 3 over 2 is still going to tend to infinity. So this whole thing here is going up to infinity, which means basically it's still problematic. So that means, so the value of the integral cannot be found. Squeezing this on here, cannot be found. Okay, so quite often that will happen. You try and fix it, and basically it's unfixable. It's still going to have a bit of a problem. So that's really what we're going to have there. Okay, Right, we're going to look at ones. It's a couple of ones where it's basically these last two here. It's you're going to have things where it's undefined at a particular point. So instead of having infinity, it's undefined at a particular point. So this one, if you put 0 into this, the limit of 0 into this, it's going to be undefined at that point. So we're going to look at what happens then. So similar to what we have just done. So again, in this one, we're going to rewrite it as the integral between a and 1 of 1 over the square root of x. And then again, that's going to be equal to the integral between a and 1 of x to the minus a half dx. And if you integrate that, you're going to get x to the power of a half. And then divide by the half is the same as multiplying by 2. So that's what you have. That's between 1 and a. And then if you put the 1 in, you'll have 2 times the square root of 1 minus 2 times the square root of a, which is just going to be 2 minus 2 root a. Now, just say as a tends to 0, remember not infinity this time, a was remember it was originally 0, a tends to 0, root of a will also tend to 0, therefore your value of your integral, so the value of the integral is 2, because remember it was 2 minus 2 times 0, so just 2 overall then. Okay, next one, it was this thing we're looking at. I'll just write that in again. It was integral of minus 1 to 1 of, what was it, 1 over x squared dx. So here what you've got to do is split this thing up. So we're going to write this slightly differently. I'm going to write from minus 1 to 0 of 1 over x squared dx. Sorry, I'll change that as well, save myself a wee bit of time. Instead of 1 over x squared, I'll write that as x to the minus 2. And plus the integral from 0 up to 1 of x to the minus 2 dx. Now we're doing this because it's going to be problematic at x equals 0, so when it's equal to 0. And then we'll just say, rewrite as the integral from minus 1, and we'll say up to a, of x to the minus 2 dx, plus the integral of b to 1 of x to the minus 2 dx. Now I call them something slightly different, so a and b, not just both a. Now the reason for that, if you think about it, just to show you what this graph would look like, that's what that graph actually looks like. So really this first one, the a is when you approach the 0 from below, so it's slightly less than 0, and the b is when you approach the 0 from above, so slightly more than 0. So they're not even the same 0. One's a negative 0, if you imagine, one's a positive 0. So that's really what's happening here, which is a bit weird. Okay, if you integrate those, first of all, if you integrate, you'll have x to the minus 1 divided by minus 1, and that's between a and minus 1. And this one is minus x to the minus 1, and that's between 1 and b. And if you fire that thing in, you're going to have minus 1 over a. Sorry, I'll do it in the square bracket. Minus 1 over a, minus, and then, sorry, minus of, and that would be minus 1. It wouldn't be minus 1, it would be minus of plus 1, apologies, minus of plus 1. And then over here, it's going to be plus, and you're going to have minus 1, and minus of minus 1 over b. So that's an absolute mess. Apologies for that. We'll tidy that up. And when you tidy up, you will have minus 1 over a, minus a 1, minus another 1, and then plus 1 over b. So what you really have, that's what you have. But we don't even need to worry about it. We'll just say as a tends to 0, 1 over a is undefined. And also, as b tends to 0, 1 over b is undefined as well. Okay, so that means, so last thing, so the value of the integral itself is, or sorry, cannot be found. Right, it seems very unsatisfying that, but that's just the way it is. That's as good as we can do at this level. You could well do something else at a different level of mathematics, but as far as we're concerned, that's all we can do.